I'm Mingfei Huang from OpenAI Lab. Thank you, everyone. Good morning. I will introduce our lab and the lab's work, OpenAI. OpenAI is our AI software platform. Okay, where's how to control it? That's why. Oh.
Behind the laptop, behind it.
Oh, okay. This is a lab. OpenAI Lab was initiated by ARM, Arena, Horizon Robotics, and ARM Accelerator in December 2016. We focus on OpenAI software for edge computing. This edge including edge gateway and device. So we focus on embedded device, it's AI software platform. Our headquarters in Shanghai also have a division in Beijing and Shenzhen. I'm based in Beijing. This is a general idea about AI. It includes training and inference. Also have cloud and edge. We focus on edge inference. So far, we haven't seen any requirements about edge training. Our focus on also is based on ARM's solution, because our background. Okay, this is our work, OpenAI. The D means distro. Okay, this is our software platform for AI on edge computing. You can see in the middle box is OpenAI. It has 3 layers. I will introduce each layer. Above that is AI applications, and below that is OS and hardware platform. Maybe we can start from hardware platform. First is SoC. We think for edge computing, the SoC will be combined CPU plus GPU plus deep learning accelerator or NPU plus DSP. This DSP maybe is a simple vector processor. Maybe some part just have CPU, DLA, and vector processor. Maybe some part have GPU. Anyway, the SoC will be a heterogeneous computing platform. For the board, we support 96 boards. That's open spec. So if we use our open software plus this open board, that will be an open AI platform. For software, we support for OS, we support Android, Linux, and RTOS. Above that is our OpenAI. OpenAI have 3 layers. The low layer is computer library. The middle layer is a framework. It's a deep learning framework or machine learning framework. Above that is domain library. It's application library, including algorithm. Okay, for the domain library, it's not only deep learning algorithm, it also including other for example, what's the mean domain? Domains now we support vision, computer vision, and speech. So in the future, we will support more domains related to some sensors. So for the above that, for the applications, if you are application user, you can call the domain library API. You don't need to know what's the deep learning framework you are using. Domain API is like, for example, you don't need to care about what algorithm. You just need to call, for example, face detection. You just need to call face detection API. You don't need to know what exact algorithm you are using. Maybe it's, for example, maybe it's based on MTCNN, this network, but you don't need to know. You also don't need to know what the framework you are using. It's Caffe or it's TensorFlow. You don't need to know that. That's a domain library. For the framework, you can see we have a very popular framework supported, like a Caffe. This Caffe is a Caffe HRT. That means HRT means heterogeneous runtime. That's optimized Caffe. But it's just for ARM's solution. Caffe HRT or MXNet HRT or TensorFlow HRT, all of them are optimized framework. We also have our own framework, it's T-Engine, but it's just for inference, not supporting training. For the T-Engine, we also support more features. Here, we named it enhanced feature, like security. Also support heterogeneous dynamic scheduling. Also support some domain operators, like that. For the low layer library, we support general BLAS library, for example, OpenBLAS or PerforBLAS. PerforBLAS is a commercial version of OpenBLAS. ARM computer library, all of them are open sourced. Caffe, whatever Caffe HRT, MXNet HRT, or TensorFlow HRT, or our T-Engine, they not only support this open source library, also support our own library. It's HCL, heterogeneous computing library. This library is based on ARM computer library. We focus on special microarchitecture, for example, Cortex A72, A53, A7. In the future, we will support more microarchitecture, also including Cortex-M. This general introduction about OpenAI. Okay, let's go, jump to more details. This optimized Caffe TensorFlow MXNet. Okay, what we did on optimization. Our optimization focused on improving performance. So first, we make Caffe to support dynamic scheduler embedded. What does that mean? First, Caffe, we make it support dynamic scheduler between CPU and GPU. the scheduler means, for example, if you're using a network, you can make the network some operator running on CPU, some operator running on GPU. So the network running will be pipeline, like that. Default cafe, all the networking running, you need to bundle the network to CPU or GPU. It cannot dynamic scheduling. Second, for the dynamic scheduling means even for CPU, we dynamically selecting operators driver from the 3 kind of library. What that mean? That means for a network, some operator their library from HCL, some from ACL, some from OpenBLAS, like that. Because in our developing, we found no any computer library is perfect for all networks. Different algorithm, different model, or different network, they use different operators. Even for convolution operator, different parameters you will see different performance using different library. So any library is perfect for all operators. So we have a dynamic scheduling select library between the 3 libraries. That's the dynamic scheduler. We also do some deep learning operator optimizing. We also, besides the optimization, we also did some work on tools. We have embedded debugging and profiling tools in embedded cafe. That's what we did on cafe, also MXNet, also TensorFlow. In the future, we may support PyDo of Baidu's framework. Okay, let's optimize the cafe, TensorFlow, and MXNet. This performance, I just use cafe HRT to compare our result. You can see this is based on Cortex-A 53. You can get this performance data from our project in GitHub. For this one, you can see we compare single core performance between Cafe and Cafe HRT and Cafe HRT with HCL. By default configuration, HRT don't support HCL. HCL need to enable. So we compare them. HCL also support quantized data, for example, int X, int 8. So we can see the performance, whatever the single core or 4 core, the performance you can see whatever an AxNet or GoGoNet or SqueezeNet or MobileNet, the performance skill is good. Okay, that's our performance result. You can get the 9.5x compared with original Cafe. Okay, that's the performance. T-Engine, okay, is our own framework. This framework just support inference. In the middle block, you can see T-Engine have a graph presentation, graph executor, scheduler, device executor, whatever the purpose. is general block for any deep learning framework. The scheduler supports CPU, GPU, DLA, or DSP, this dynamic scheduling. That means if one network or model, it can running on some operator can running on CPU, some operate on GPU, some can be on DLA, some will be on DSP. You may ask why you already have DLA, you still need CPU or DSP or vector processor to running some operators. That's because the DLA or NPU, their operator are fixed. This means if you have new operator coming or your network is special, not supported by this DLA, you have problem to running the whole network on the DLA or NPU. So you need some extended operator supported by vector processor or CPU. So that's why we need this dynamic scheduling for this heterogeneous computing platform. Okay, that's one feature for this inference engine. Another very important feature is if you are a user for Caffe or TensorFlow, you don't want to change your software from Caffe framework to T-Engine, but you still want to use T-Engine to get better performance. So what we can do, in fact, the T-Engine, we have Caffe, TensorFlow, and MaxNet API interface. That means our API interface are compatible with this traditional framework. So if you are using Caffe, you don't need to change your software. You just link to this T-Engine's library. You can make it run. Another more important is we support Caffe and MaxNet TensorFlow's models, pre-trained models. You don't need to translate that to another model. We support it. You just need to load it and run it. We also support ONNX, this like a standard model. Okay, this T-Engine. This performance. This just compares the CPU's performance. We compare Caffe and the optimized Caffe and T-Engine. We compare the flow point, also compare the quantized. You can see whatever we get better performance. We use the SqueezeNet and MobileNet as benchmark because in the embedded device, the small network is more popular. Okay, this T-Engine's performance. So you can see we get the better performance even than our optimized Caffe. For this case, we can get 2.46x performance. Okay, this domain library. Now, domain library we haven't released it. In GitHub, we just have some open source algorithm there. But domain library will be released in middle of this year. But the algorithm, we already released some that open source. This is a list with some performance. I haven't listed the accuracy, but you can get accuracy data in GitHub. You can see we have face detection, face recognition, object tracking, gesture recognition, and speech recognition. For this speech recognition, it's not, the performance is running on the device. It's based on ARM Cortex-A72. Okay, this performance is running on that single core performance. For this speech recognition, it means it's a voice command. That means all the requirement is from some home device or robotics. It needs local voice to handle for voice command. This just is for 100 voice command supported. We have other versions. This one is based on is KD based. We porting from KD. We make it smaller. We use GMM, HMM model. We have also other models. We also have non-KD based speech recognition algorithm. It will be upload to GitHub later. Okay, all of these algorithm list except third parties algorithm, all of them are in GitHub. For example, face detection, we use the MTCN, this algorithm. Okay, in this just algorithm. In the future, domain library upstreamed, you will see the algorithm will be packaged into the domain library. You don't need to call the algorithm directly. You just need to call domain library API interface. In fact, for supporting this algorithm and our framework, we have more tools beside the tools in the device. We also have some server tools. That means that we'll be running whatever ARM server or x86 server is for retraining and quantizing. We have this kind of tools to support this local framework. Okay, this our cooperate with 96 boards. If you use our OpenAI plus 96 boards, you will get an open platform. So now we have OpenAI runs on HKG18 Dragon board, 820C, and Rock 960. All of the solutions are ARM-based. Okay. This is our link. You can get almost everything from this GitHub link. Okay, the picture is small, but anyway, you can see T-Engine, Cafe HRT, some algorithms are there. Yeah, you can get the things in this GitHub. Okay, you can get support from this email address. Thank you.
Thank you so much, Mingfei.